On July 1st, 2025, a routine survey telescope in Chile picked up something that shouldn't exist. A faint dot moving against the background stars, but not like anything astronomers had seen before. Within hours, the data confirmed what seemed impossible. Humanity had just detected its third visitor from beyond our solar system. But this one was different. This one was about to ignite the biggest scientific controversy of the decade and force us to confront a terrifying possibility about what's really out there in the darkness between stars. The object, now designated 3I/Atlas, appeared as nothing more than a smudge of light when the Atlas Survey telescope first captured it racing through space. But as observatories around the world turned their instruments toward this cosmic intruder, the measurements revealed something that sent shockwaves through the astronomy community. This wasn't just another chunk of ice and rock drifting aimlessly through the void. The trajectory calculations showed an object moving at incredible velocity, following a hyperbolic path that could only mean one thing. It originated from another star system entirely. Dr. Sarah Martinez was working the night shift at the Cerro Tololo Inter-American Observatory when the first alerts started flooding her computer screen. As the lead astronomer for the Atlas project, she'd seen thousands of asteroid detections over the years, but something about this one made her pause. The object was moving too fast, its brightness fluctuating in patterns that didn't match any known celestial body in their databases. She immediately began cross-referencing the observations with other telescopes, and within 6 hours, the impossible became undeniable. The discovery protocol for potentially hazardous objects kicked into high gear, but this wasn't about planetary defense. This was about something far more extraordinary. As Martinez and her team refined their measurements throughout that first night, they realized they were witnessing history in the making. The object's velocity and trajectory placed it firmly in the category of interstellar visitors, making it only the third confirmed object from beyond our solar system ever detected by human instruments. Martinez had been part of the team that discovered several near-Earth asteroids, including one that had required emergency tracking by NASA's Planetary Defense Office. But this was entirely different. The calculations showed 3I/Atlas was traveling at roughly 60 kilometers per second, a speed so extraordinary that it could only be achieved by an object ejected from another star system with tremendous force. The energy required to accelerate something to such velocity suggested violent processes at work in distant corners of the galaxy, stellar explosions or gravitational slingshots around massive objects that had flung this wanderer into the void millions of years ago. What made the discovery even more remarkable was how close they'd come to missing it entirely. The Atlas survey system was designed to detect potentially hazardous near-Earth objects, not interstellar visitors. If 3I/Atlas had passed through a slightly different region of space, or if atmospheric conditions that night had been less favorable, humanity might never have known about this cosmic messenger from another world. The realization that such objects could slip by undetected was both thrilling and deeply unsettling. Within 48 hours of the initial detection, observatories across 6 continents had confirmed the object's interstellar nature. The European Southern Observatory's Very Large Telescope in Chile provided detailed spectroscopic data, while radio telescopes in Australia and Puerto Rico searched for any electromagnetic signals. The international collaboration that emerged was unprecedented, with research teams sharing data in real time and coordinating observations to maximize the scientific return from this rare encounter. The early measurements revealed an object roughly 200 meters across, significantly larger than the first interstellar visitor, Oumuamua, which had been perhaps 100 meters long but only 35 meters wide. Unlike that oddly elongated predecessor, 3I/Atlas appeared to have a more conventional shape, though its exact dimensions remained difficult to determine due to its tumbling motion and the way it reflected sunlight. What was immediately clear was that this visitor was substantial enough to study in detail, offering the first real opportunity to analyze materials from another star system using Earth-based instruments. Dr. Martinez found herself at the center of a media storm as news of the discovery spread beyond the scientific community. Reporters called at all hours, asking whether the object posed any threat to Earth and what its discovery meant for our understanding of the galaxy. She carefully explained that 3I/Atlas would pass safely through the outer solar system without approaching anywhere near Earth, but the implications of its existence were profound. This wasn't just another space rock, It was a time capsule from another world, carrying information about stellar systems and planetary formation processes that existed nowhere else in our cosmic neighborhood. The discovery also rekindled debates about how common such visitors might be. Theoretical models had suggested that interstellar objects should be relatively rare, with perhaps one detectable visitor every few years. But with 3 confirmed objects found in just 8 years, astronomers began to suspect that the space between stars was far more crowded than anyone had imagined. If current detection rates were any indication, dozens or even hundreds of interstellar wanderers might be passing through our solar system at any given time, most too small or dark to spot with existing technology. The implications were staggering. If interstellar objects were common, they represented a previously unknown mechanism for exchanging materials between star systems. Organic compounds, water, and even potentially life itself could be spreading throughout the galaxy on these cosmic vessels, seeding new worlds with the ingredients for biology. The concept of panspermia, life spreading between planets and stars, suddenly seemed not just possible, but inevitable. But even as the scientific community celebrated this remarkable discovery, troubling questions began to emerge. The object's behavior as it approached the inner solar system would soon reveal anomalies that challenged every assumption about what interstellar visitors should look like. And one prominent astronomer was about to propose an explanation so controversial that it would divide the scientific world and capture the imagination of millions of people around the globe. Within days of its discovery, 3I/Atlas began displaying behavior that defied easy explanation. Most comets remain inactive until they approach close enough to the sun for solar radiation to begin sublimating their icy surfaces, typically inside the orbit of Jupiter. But this visitor started showing signs of outgassing while still far beyond Jupiter's orbit, much earlier than any natural comet should become active. Telescopes detected a faint coma forming around the object, and spectroscopic analysis revealed gases being expelled at rates that seemed inconsistent with its size and distance from the sun. Dr. James Chen, at the Harvard-Smithsonian Center for Astrophysics, was among the first to notice the peculiarities. His team had been monitoring the object around the clock using the institution's network of affiliated telescopes, and the data they were collecting painted a picture of something that didn't quite fit any existing models. The gases being expelled weren't just water vapor and carbon dioxide, as expected from a typical comet. Instead, they detected exotic compounds, nitrogen-bearing molecules, sulfur compounds, and complex hydrocarbons that suggested formation in an environment very different from our solar system. The chemical signatures were particularly intriguing because they indicated formation conditions unlike anything found around our sun. The ratios of different isotopes suggested that 3I/Atlas had originated near a star with different metallicity than our sun, possibly a younger, more massive star surrounded by different types of planetary building materials. This made the object a unique laboratory for studying stellar system formation processes that had occurred light years away and millions of years in the past. Even more puzzling was the pattern of the outgassing. Instead of the random chaotic release typically seen in comets as they heat up, 3I/Atlas seemed to be expelling material in structured bursts. The emissions would intensify and fade in what appeared to be regular cycles, creating patterns in the developing tail that some researchers described as almost rhythmic. Chen and his colleagues spent sleepless nights analyzing the data, looking for natural explanations for what they were observing. But each new measurement seemed to deepen the mystery rather than resolve it. The object's rotation also presented anomalies that caught the attention of researchers worldwide. Most asteroids and comets tumble through space in predictable patterns, determined by their shape and the forces that set them spinning. But 3I/Atlas displayed a rotation that seemed unusually stable, almost as if something was actively controlling its orientation. The period was remarkably consistent, showing none of the irregularities that should result from outgassing jets pushing against an asymmetric surface. Dr. Elena Kowalski, at the European Space Agency's Space Situational Awareness Program, was tasked with modeling the object's trajectory and predicting its future path through the solar system. Her initial calculations showed that 3I/Atlas would make its closest approach to the Sun in late October 2025, passing well inside the orbit of Earth, but posing no collision risk to any planet. However, As she refined her models using increasingly precise observational data, she noticed something that made her double-check her calculations multiple times. The object's path through the solar system was almost too perfect. Its trajectory would carry it past several planets at distances that would provide optimal viewing angles for anyone, or anything, aboard the object to observe these worlds. The path would offer detailed looks at Mars, Earth, and Venus, almost as if the route had been planned to conduct reconnaissance of the inner solar system's terrestrial planets. While this could certainly be coincidental, the precision of the trajectory was statistically unlikely for a random interstellar wanderer. Kowalski shared her findings with colleagues who initially dismissed them as an interesting coincidence. Random objects entering the solar system would naturally follow paths determined by the sun's gravity and their initial velocity, and some of those paths would inevitably provide good viewing angles of various planets. But as more detailed orbital analysis became available, the coincidence seemed increasingly remarkable. The trajectory wasn't just providing casual glimpses of planets, it was offering extended observation opportunities at ranges that would maximize the scientific return from any hypothetical instruments aboard the object. The speculation that followed these revelations was intense, but largely confined to private conversations between researchers. Publicly, scientists maintained that 3I/Atlas was almost certainly a natural object, probably a comet or asteroid ejected from its home system during planetary formation or stellar evolution processes. But privately, some began to wonder whether they were witnessing something unprecedented in human experience. The timing of the discovery also seemed remarkably fortuitous. Humanity's detection capabilities had only recently become sophisticated enough to spot objects like 3I/Atlas. If the visitor had arrived even a decade earlier, it might have passed through unnoticed. The fact that it appeared just as our technology reached the threshold for detection raised questions about whether its arrival was coincidental or somehow timed to coincide with humanity's emerging ability to recognize interstellar visitors. Additional observations revealed more puzzling characteristics. The object's albedo, its reflectivity, varied across its surface in patterns that didn't match typical comets or asteroids. Some regions appeared highly reflective, almost metallic, while others absorbed light like the darkest materials found in space. This patchwork of light and dark suggested either an unusual composition or surface features unlike anything seen on natural solar system bodies. The electromagnetic signature of 3I/Atlas also raised eyebrows among researchers monitoring it with radio telescopes. While the object didn't emit any obvious artificial signals, its interaction with the solar wind created electromagnetic effects that were unusually structured. Some researchers described these patterns as almost like a signature or fingerprint, though they couldn't identify any natural process that would create such organized electromagnetic behavior. As weeks passed and observations continued, the mystery of 3I/Atlas only deepened. Each new measurement seemed to reveal another anomaly, another characteristic that didn't quite fit the standard model of interstellar comets. The scientific community found itself in the uncomfortable position of studying an object that challenged fundamental assumptions about what natural visitors from other star systems should look like. The stage was set for a controversy that would soon explode into public view, dividing astronomers and capturing global attention. One of Harvard's most prominent and controversial researchers was about to propose an explanation for 3I/Atlas's anomalies that would force humanity to confront the possibility that we were not alone in the universe, and that we might be under observation by intelligences far more advanced than our own. But that bombshell theory would have to wait until more data could be collected and analyzed. For now, 3I/Atlas continued its silent journey through the outer solar system, carrying with it secrets that could revolutionize our understanding of our place in the cosmos. The greatest scientific detective story of the 21st century was just beginning, and its resolution would determine whether humanity was ready to accept that the universe might be far stranger and more populated than we had ever dared to imagine. Just when the scientific community was beginning to wrap their heads around 3I/Atlas's anomalies, Harvard professor Avi Loeb dropped a bombshell that would divide astronomers and capture global attention. On August 15th, 2025, Loeb and his colleagues published a controversial paper that suggested something most scientists considered unthinkable. that 3I/Atlas might not be a natural object at all. Instead, they proposed it could be a piece of alien technology, possibly even a spacecraft deliberately navigating through our solar system. Loeb's theory wasn't based on wild speculation, but on the same puzzling data that had been keeping astronomers awake at night. The unusual speed, the pristine condition despite its interstellar journey, the structured outgassing patterns, and the seemingly optimized trajectory all pointed to something that didn't fit the standard comet model. If this was artificial, Loeb argued, it would explain every anomaly perfectly. An advanced civilization's probe could maintain its integrity across interstellar distances using technology beyond our understanding. Its apparent outgassing could be exhaust from propulsion systems rather than natural sublimation. The Harvard professor had a history of controversial statements about potential alien technology. He'd previously suggested that Oumuamua, the first detected interstellar visitor, might have been artificial due to its unusual acceleration and elongated shape. That theory had been largely dismissed by the astronomical community, but Loeb's reputation as a brilliant theorist meant his ideas couldn't be ignored entirely. Now, with 3I/Atlas displaying even more puzzling characteristics, his alien probe hypothesis was gaining attention from researchers who had previously dismissed such possibilities. Loeb's analysis focused on what he called the coincidence problem. The probability of a random interstellar object following a trajectory that would provide optimal observation angles of multiple terrestrial planets was astronomically low, perhaps 1 in several million. Combined with the object's unusual behavior, this suggested either extraordinary luck or intentional design. Given the choice between an incredibly improbable natural occurrence and the possibility of artificial guidance, Loeb argued that scientific principle demanded considering the artificial explanation. But the Harvard professor went even further in his controversial paper, suggesting that if 3I/Atlas was indeed artificial, its trajectory through our solar system might represent a reconnaissance mission. The object wasn't just passing by randomly, it was following a path that would give any onboard systems optimal observation opportunities of our planets, particularly Earth and Mars. This raised the disturbing possibility that humanity was being studied, evaluated, or even surveyed by an intelligence from another star system. The implications were staggering and terrifying. If Loeb was right, this wouldn't just be the discovery of alien life, it would be first contact, and we might not even realize it was happening. The object would represent technology so advanced that it could traverse interstellar space, maintain operational capability for potentially millions of years, and conduct reconnaissance missions in foreign star systems. The thought that such a civilization might exist and might be observing us without our knowledge sent chills through anyone who seriously considered the possibilities. Loeb's paper also addressed the electromagnetic anomalies that radio telescopes had detected. While 3I/Atlas wasn't broadcasting any obvious artificial signals, its interaction with the solar wind created structured electromagnetic patterns that seemed too organized to be entirely natural. Loeb suggested these could be the byproduct of active systems aboard the object, perhaps shielding technology or passive sensors designed to gather information about the solar environment and any electromagnetic signatures from planetary civilizations. The chemical composition anomalies also fit Loeb's artificial probe theory. The exotic compounds and unusual isotope ratios detected in the object's outgassing could represent manufactured materials or fuel byproducts rather than natural comet ice. The structured rhythmic pattern of gas release looked more like controlled venting from artificial systems than the chaotic sublimation expected from a natural comet. Even the object's unusually stable rotation could indicate active attitude control systems, maintaining optimal orientation for sensors or communication equipment. Dr. Rebecca Torres, a planetary scientist at MIT who had initially been skeptical of Loeb's theories, found herself reconsidering after reviewing the accumulating evidence. The trajectory analysis was particularly compelling. She had run her own calculations and confirmed that the probability of a natural object randomly following such an optimal observation path was indeed vanishingly small. While she wasn't ready to endorse the alien probe hypothesis, she admitted that conventional explanations were becoming increasingly strained. The media reaction to Loeb's theory was explosive. Within hours of the paper's publication, news outlets around the world were running headlines about potential alien visitors and extraterrestrial surveillance. Social media platforms buzzed with speculation, conspiracy theories, and demands for more information from government agencies. The hashtag alien probe began trending globally, and UFO enthusiasts pointed to 3I/Atlas as validation of their beliefs about extraterrestrial visitation. But not everyone was impressed by Loeb's reasoning. Dr. Michael Rodriguez at the California Institute of Technology published a scathing critique, arguing that the alien probe hypothesis was premature and potentially damaging to serious scientific discourse. Rodriguez pointed out that unusual doesn't necessarily mean artificial, and that the history of astronomy was filled with natural phenomena that initially seemed impossible to explain. He argued for patience and continued observation rather than jumping to extraordinary conclusions. The scientific community found itself deeply divided. Younger researchers, perhaps more open to revolutionary ideas, were more likely to consider Loeb's theory seriously. Established astronomers with decades of experience studying natural solar system objects tended to dismiss the alien probe hypothesis as sensational speculation. The divide wasn't just about scientific interpretation. It reflected deeper philosophical differences about how to approach anomalous data and what constitutes reasonable scientific speculation. International space agencies found themselves in an awkward position. NASA issued carefully worded statements emphasizing that 3I/Atlas appeared to be a natural object, while acknowledging that its unusual characteristics warranted continued study. The European Space Agency took a similar approach, neither endorsing nor dismissing Loeb's theory, but calling for more observations and analysis. Behind the scenes, however, contingency plans were quietly being developed for various scenarios, including the possibility that the object might indeed prove to be artificial. The Pentagon's All-Domain Anomaly Resolution Office, responsible for investigating unidentified aerial phenomena, began quietly coordinating with NASA to monitor 3I/Atlas more closely. While they made no public statements about potential artificial origins, their involvement signaled that government agencies were taking the possibility seriously enough to warrant intelligence community attention. The implications for national security, if an advanced extraterrestrial civilization was conducting surveillance of Earth, were too significant to ignore. As August turned to September, the debate over 3I/Atlas's nature intensified rather than resolved. Each new observation seemed to provide evidence that could support either the natural comet theory or the artificial probe hypothesis, depending on how the data was interpreted. The object continued its journey toward the inner solar system, carrying with it the hopes and fears of a species suddenly confronted with the possibility that we were not alone, and that we might be under observation by intelligences far more advanced than our own. The response from NASA and the broader scientific establishment was swift, decisive, and often harsh. While they respected Loeb's credentials and his right to propose alternative theories, most astronomers rejected the alien spacecraft hypothesis as premature, sensational, and potentially damaging to serious scientific research. The reaction revealed deep divisions within the astronomical community about how to handle anomalous data and the appropriate threshold for extraordinary claims. Dr. Jennifer Walsh, director of NASA's Planetary Defense Coordination Office, held a press conference on August 20th to address the growing public interest in 3I/Atlas. She emphasized that the object displayed characteristics broadly consistent with a natural comet, albeit an unusual one from another star system. The early onset of outgassing, rather than indicating artificial propulsion systems, likely reflected the object's exotic composition, volatile ices that formed under different conditions than those found in our solar system and responded differently to solar heating. Walsh's team had been working around the clock to model 3I/Atlas's behavior using established comet physics, and they'd made significant progress in explaining many of the anomalies. The structured outgassing patterns could result from the object's internal structure, layers of different materials that sublimated at different rates as the object warmed up. The unusual electromagnetic signature might be explained by the object's high metal content, creating more complex interactions with the solar wind than typically seen in ice-rich comets. The trajectory issue, while statistically unlikely, wasn't impossible according to NASA's analysis. Computer simulations showed that objects ejected from certain types of stellar systems could indeed follow paths that would provide good observation angles of multiple planets in any target system they entered. The key was the initial conditions when the object was first ejected from its home system. The right combination of velocity and direction could create trajectories that seemed improbably convenient, but were actually the natural result of gravitational dynamics. Dr. Carlos Mendez at the Jet Propulsion Laboratory took a more direct approach in challenging Loeb's theory. His team published detailed spectroscopic analysis showing that 3I/Atlas's chemical composition, while unusual, was entirely consistent with formation in certain types of stellar environments. The exotic compounds and isotope ratios could be explained by formation near a young metal-rich star, or in a stellar system with different planetary formation processes than our own. There was no need to invoke artificial manufacturing to explain the object's chemistry. Mendez also addressed the rotation anomalies that had puzzled researchers. His analysis suggested that 3I/Atlas might have an unusually dense core surrounded by a lighter mantle, a structure that would naturally create the stable rotation pattern observed. This could result from the object's formation process, or from partial disruption during its ejection from its home system. Such internal structure would also explain the patchy surface reflectivity, as different materials would be exposed in different regions. The electromagnetic effects that had seemed so mysterious could be explained by the object's composition and structure. If 3I/Atlas contained significant amounts of metallic materials, perhaps from a disrupted planetary core, it would interact with the solar wind in ways that created structured electromagnetic patterns. These weren't evidence of artificial systems, but rather the natural consequence of a metal-rich object moving through the solar system's magnetic environment. Other prominent astronomers joined the criticism of Loeb's theory. Dr. Susan Chen at the University of Arizona argued that the alien probe hypothesis violated Occam's razor, the principle that the simplest explanation is usually correct. While 3I/Atlas was certainly unusual, invoking extraterrestrial technology to explain its properties was far more complex than proposing natural processes we simply didn't fully understand yet. The history of astronomy was filled with phenomena that seemed impossible until new physics or better observations provided natural explanations. The scientific criticism wasn't just about the specific claims regarding 3I/Atlas. Many researchers worried about the broader implications of seriously entertaining alien technology hypotheses without overwhelming evidence. They argued that such speculation, especially when promoted by respected institutions like Harvard, could damage public trust in scientific methodology and provide ammunition for conspiracy theorists and pseudoscience promoters. Dr. Patricia Rodriguez at the European Southern Observatory expressed concerns about the media coverage surrounding Loeb's theory. She argued that sensational claims about alien visitors distracted from the genuine scientific value of studying interstellar objects. Whether 3I/Atlas was natural or artificial, it represented an unprecedented opportunity to analyze materials from another star system and learn about planetary formation processes in different stellar environments. The focus on extraterrestrial intelligence detracted from this important research. However, not all criticism of Loeb's theory was dismissive. Some researchers acknowledged that while the alien probe hypothesis was unlikely, the anomalies observed in 3I/Atlas were real and significant. Dr. Mark Thompson at the Royal Observatory, Greenwich, published a thoughtful analysis, arguing that the object deserved careful study precisely because it didn't fit standard models. Whether the explanation turned out to be exotic natural processes or something more extraordinary, understanding 3I/Atlas would advance human knowledge of interstellar objects and stellar system evolution. The debate also revealed generational and institutional divides within the astronomical community. Younger researchers, particularly those working on SETI projects or exoplanet research, were more open to considering artificial explanations for 3I/Atlas's anomalies. They argued that the discovery of thousands of exoplanets had demonstrated that the galaxy was full of planetary systems, making the existence of advanced civilizations statistically probable. If such civilizations existed, it was reasonable to consider whether their technology might be detectable in objects like 3I/Atlas. Older, more established astronomers tended to be more conservative, emphasizing the need for extraordinary evidence before accepting extraordinary claims. They pointed to the long history of natural phenomena initially thought to be artificial, from pulsars to fast radio bursts, that eventually received conventional explanations. The burden of proof, they argued, should be on those claiming artificial origins to definitively rule out natural explanations. The controversy also highlighted different approaches to scientific communication and public engagement. Loeb defended his decision to publish and promote his theory, arguing that science progressed through open debate and that the public had a right to know about potentially significant discoveries. His critics countered that premature speculation about alien technology could mislead the public and damage the credibility of serious astronomical research. Behind the public debates, however, practical concerns were driving increased attention to 3I/Atlas. Space agencies around the world quietly began developing contingency plans for various scenarios, including the possibility that the object might indeed prove to be artificial. While officially maintaining that natural explanations were most likely, these agencies recognized their responsibility to prepare for all possibilities, however unlikely. The military and intelligence communities also took notice. The potential implications of an advanced extraterrestrial probe conducting surveillance of Earth were too significant to ignore, regardless of how improbable such a scenario might be. Classified assessments were conducted, and monitoring protocols were established to track 3I/Atlas's behavior as it continued its approach toward the inner solar system. As September progressed, the scientific civil war over 3I/Atlas showed no signs of resolution. If anything, the positions became more entrenched as researchers invested their reputations in their interpretations of the data. The object itself remained indifferent to human debates, continuing its journey through the outer solar system, while carrying secrets that would soon put both theories to the ultimate test. The approaching close encounter with the Sun would provide unprecedented opportunities for observation and potentially decisive evidence for determining whether humanity was witnessing a natural wonder or something far more extraordinary. As the controversy raged in academic circles and social media, astronomers continued studying 3I/Atlas with increasingly sophisticated instruments, and the more they learned, the stranger it became. The object's velocity wasn't just high, it was precisely high, moving at a speed that seemed almost calibrated for its interstellar journey. Computer simulations showed that objects ejected from star systems typically follow predictable velocity distributions based on the gravitational dynamics of their ejection events, but 3I/Atlas sat at the extreme edge of what natural processes should produce. Dr. Yuki Tanaka at the Tokyo Institute of Technology had been running complex orbital mechanics calculations since the object's discovery, trying to trace its path backward through space and time to determine its origin. Her team's supercomputer models painted a disturbing picture. For 3I/Atlas to achieve its current velocity through natural ejection processes, it would have required an encounter with an exceptionally massive object, perhaps a close pass by a black hole or neutron star, or ejection during a supernova explosion. But objects surviving such violent events should show clear signs of thermal or gravitational damage, neither of which were evident in 3I/Atlas. The precision of the velocity was what troubled Tanaka most. Natural ejection events create a range of exit velocities depending on countless variables: the exact trajectory past the massive object, the rotation of the ejecting body, interactions with stellar winds, and gravitational perturbations from other objects. Yet 3I/Atlas seemed to have achieved exactly the right speed to reach our solar system at exactly the right time to follow its current trajectory. The mathematical probability of such precision occurring by chance was vanishingly small. Even more intriguing was how the object maintained its trajectory with such remarkable stability. Unlike previous interstellar visitors that showed slight deviations due to solar radiation pressure and gravitational influences from planets, 3I/Atlas remained locked on its course with minimal variation. Advanced trajectory modeling revealed that the object was making microscopic adjustments to its path, corrections so subtle they were almost undetectable, but perfectly timed to maintain optimal positioning for observing the inner planets. Dr. Andreas Müller at the Max Planck Institute for Extraterrestrial Physics was among the first to notice these trajectory microcorrections. His team had been using the most sensitive astrometry techniques available, measuring the object's position to within fractions of an arc-second over time periods of days. The data revealed tiny but consistent deviations from a purely gravitational orbit, adjustments that could be explained by the object's shape and rotation if those factors remained perfectly constant, but which seemed unlikely to maintain such precision naturally. The sublimation patterns added another layer of mystery that deepened with each observation. As 3I/Atlas approached the Sun, it began releasing gases and particles in ways that defied standard comet models. The emissions seemed to pulse rhythmically, creating patterns in the developing tail that resembled structured signals rather than random outgassing. High-resolution spectroscopy revealed that different types of gases were being released in coordinated sequences, first nitrogen compounds, then carbon-based molecules, followed by water vapor and exotic hydrocarbons. Dr. Lisa Park at the Smithsonian Astrophysical Observatory had been monitoring these emission patterns around the clock, and what she discovered kept her awake at night. The gas releases followed mathematical sequences, Fibonacci numbers, prime number series, and other patterns that seemed too organized to be coincidental. When she first noticed the correlations, Park thought she was seeing patterns that weren't really there, a common pitfall in data analysis. But multiple independent reviews of her work confirmed the mathematical relationships in the emission timing. The implications were staggering. Natural comets outgassed chaotically as different regions of their surface heated up at different rates. The structured mathematical patterns observed in 3I/Atlas suggested either an internal structure so perfectly organized that it could produce these sequences naturally, which seemed impossible, or active control systems managing the gas releases deliberately. Park found herself in the uncomfortable position of documenting what appeared to be artificial behavior while trying to maintain scientific objectivity. Spectroscopic analysis revealed chemical signatures that continued to puzzle researchers. The exotic compounds being expelled weren't just unusual, they were optimized. The molecular structures seemed designed for maximum visibility and detectability by exactly the types of instruments humanity used to study comets. It was as if whoever or whatever had created these materials wanted them to be noticed and analyzed by civilizations with technology similar to our own. Dr. Robert Kim at the Harvard-Smithsonian Center for Astrophysics made an even more disturbing discovery when he analyzed the isotopic ratios in 3I/Atlas's emissions. The ratios weren't just different from solar system materials, they were different in specific ways that seemed to encode information. Binary patterns appeared in the distribution of heavy and light isotopes, creating what looked suspiciously like a mathematical code embedded in the object's very composition. Kim's analysis suggested that if someone wanted to send a message across interstellar distances using physical materials rather than electromagnetic signals, encoding information in isotopic ratios would be an elegant solution. Such messages would survive the million-year journey between stars and would be immediately recognizable to any civilization sophisticated enough to conduct spectroscopic analysis. The question was whether humanity was witnessing natural processes that coincidentally resembled artificial patterns, or whether they were actually decoding a message from another civilization. The electromagnetic signature of 3I/Atlas also continued to evolve in ways that defied easy explanation. Radio telescopes monitoring the object detected increasingly complex interactions between its material emissions and the solar wind. These weren't random electromagnetic effects, but structured patterns that seemed to change deliberately as the object moved through different regions of the solar magnetic environment. Dr. Maria Santos at the Arecibo Observatory successor facility had been tracking these electromagnetic patterns and found correlations with known human radio transmissions. It appeared that 3I/Atlas was somehow responding to or modulating its emissions based on radio signals originating from Earth. The effect was subtle but consistent. When powerful radio transmitters on Earth broadcasted, the object's electromagnetic signature would shift in specific ways, as if acknowledging or responding to the signals. The discovery sent chills through the radio astronomy community. If 3I/Atlas was naturally responding to Earth's radio emissions, it suggested electromagnetic properties unlike any known natural object. If the responses were artificial, it meant that something aboard the object was monitoring Earth's electromagnetic environment and potentially our communications. Either explanation challenged fundamental assumptions about physics or the uniqueness of human intelligence in the galaxy. Government agencies began taking a more active interest in these developments. The National Security Agency quietly reached out to radio astronomy facilities, requesting detailed logs of any unusual electromagnetic behavior associated with 3I/Atlas. While no official statements were made, the implication was clear. If an extraterrestrial probe was monitoring Earth's communications, it represented a potential intelligence threat that needed to be assessed and understood. International cooperation on 3I/Atlas observations began to include classified elements as various nations' space agencies coordinated with their defense and intelligence services. The European Space Agency, Japan's JAXA, and even Russia's Roscosmos began sharing data through secure channels, recognizing that the implications of an artificial interstellar visitor transcended normal scientific collaboration. As October approached and 3I/Atlas continued its journey toward the inner solar system, the accumulating evidence painted a picture that was becoming increasingly difficult to explain through natural processes alone. The mathematical patterns in its emissions, the precision of its trajectory, the apparent responsiveness to Earth's radio signals, and the optimized chemistry of its outgassing all suggested something that challenged the conventional wisdom about what interstellar objects should look like. Yet the scientific community remained deeply divided. For every anomaly that suggested artificial origins, researchers proposed natural explanations that, while increasingly complex and unlikely, remained theoretically possible. The debate wasn't just about 3I/Atlas anymore. It had become a philosophical battle about the nature of scientific evidence and the threshold for accepting revolutionary conclusions. What truly shocked astronomers wasn't just 3I/Atlas itself, but what its discovery revealed about the hidden architecture of our galaxy. Follow-up surveys using the same detection methods that found the interstellar visitor began uncovering evidence that such objects might be far more common than anyone had imagined. The space between stars, once thought to be largely empty, appeared to be teeming with wandering bodies ejected from distant solar systems, a discovery that fundamentally changed our understanding of galactic dynamics and the potential for life to spread throughout the Milky Way. Dr. Catherine Reynolds at the University of Arizona had been conducting a systematic search for additional interstellar objects using an expanded version of the Atlas survey system. Her team's preliminary results, released in early September, suggested that at any given moment, there could be dozens of interstellar objects passing through our solar system undetected. Most would be too small or too dark to spot with current technology, but they were there, silent witnesses to the violent histories of countless star systems across the galaxy. The statistical analysis was startling. Based on the detection rate of confirmed interstellar visitors and the known limitations of current survey technology, Reynolds estimated that interstellar objects might actually outnumber local solar system bodies in certain size ranges. The outer regions of our solar system could be hosting a constant parade of cosmic wanderers, most passing through unnoticed on trajectories that would carry them back into the void between stars. This revelation transformed our understanding of how solar systems interact across galactic distances. Rather than being isolated islands of matter orbiting individual stars, planetary systems appeared to be connected by streams of ejected material flowing between them like cosmic rivers. Objects launched from one star system could seed others with organic compounds, water, and potentially even life itself. The galaxy wasn't a collection of separate systems, but an interconnected web of matter and information exchange operating on timescales of millions of years. Dr. Ahmad Hassan at the Observatoire de Paris had been studying the orbital characteristics of known interstellar objects and discovered something even more remarkable. The visitors didn't appear to be arriving randomly from all directions. Instead, there seemed to be preferred arrival vectors, as if interstellar objects were following specific galactic streaming patterns. His analysis suggested that our solar system might be positioned along one or more interstellar highways, regions where gravitational influences from nearby stars created natural corridors for ejected objects. The implications for astrobiology were profound and potentially revolutionary. If interstellar objects regularly carried materials between star systems, then the ingredients for life, or even life itself, could spread throughout the galaxy over cosmic timescales. Panspermia, the theory that life spreads between planets and star systems, suddenly seemed not just possible, but inevitable. 3I/Atlas and its fellow travelers might be carrying microscopic hitchhikers from their home systems, organisms that could seed new worlds with alien biology. Dr. Sarah Mitchell at the NASA Astrobiology Institute began developing protocols for detecting potential biological materials on interstellar visitors. Her preliminary studies suggested that if life existed elsewhere in the galaxy, interstellar objects would be the most likely vectors for its spread. Organisms capable of surviving the harsh conditions of interstellar space, extreme cold, radiation, and millions of years of dormancy could theoretically travel between star systems and potentially take root in new environments. The discovery of interstellar streaming patterns also raised disturbing questions about 3I/Atlas's seemingly optimized trajectory. If interstellar objects naturally followed specific galactic pathways, then an object arriving from a particular direction might indeed be more likely to follow certain orbital paths through our solar system. What had seemed like impossible coincidence might actually be the predictable result of galactic gravitational dynamics that humanity was only beginning to understand. However, this natural explanation couldn't account for all of 3I/Atlas's anomalies. Even if galactic streaming made certain trajectories more probable, the precision with which the object maintained its optimal observation path still suggested active guidance. The mathematical patterns in its emissions and the apparent responsiveness to Earth's radio signals remained difficult to explain through natural galactic processes alone. Dr. Kevin O'Brien at the Dublin Institute for Advanced Studies proposed a hybrid theory that attempted to reconcile natural galactic processes with 3I/Atlas's apparent artificial characteristics. His model suggested that advanced civilizations might use natural interstellar streaming patterns as transportation networks, launching probes or spacecraft along established galactic highways to reach distant star systems more efficiently. Such a strategy would combine natural gravitational dynamics with artificial guidance systems, creating hybrid natural-artificial trajectories that were both probable and precisely controlled. O'Brien's theory had the advantage of explaining both the increasing evidence for interstellar streaming and the specific anomalies observed in 3I/Atlas. If the object was indeed an artificial probe, its creators might have used natural galactic dynamics to plan its route while employing active guidance systems to fine-tune its trajectory for optimal observation opportunities. This would explain why the object's path seemed both naturally probable and artificially precise. The hidden galactic architecture revealed by interstellar object studies also suggested that our solar system's history might be more complex than previously understood. If interstellar visitors had been arriving regularly throughout the solar system's 4.6 billion year history, they could have contributed significant amounts of exotic materials to planetary formation processes. Earth itself might contain materials from dozens of different star systems, incorporated during the early bombardment periods when interstellar visitors would have had higher probabilities of impact. Dr. Jennifer Wong at the California Institute of Technology began analyzing meteorite samples and lunar rocks for isotopic signatures that might indicate interstellar origins. Her preliminary results suggested that some of the most unusual chemical compositions found in ancient solar system materials might indeed represent contributions from interstellar visitors. The implications were staggering. Earth's biosphere might have been shaped by materials from across the galaxy, making our planet a cosmic melting pot of interstellar chemistry. The research also revealed that interstellar streaming patterns were dynamic, changing over millions of years as stars moved through their galactic orbits and gravitational influences shifted. Our solar system's current position along interstellar highways might be temporary, suggesting that the rate of interstellar visitors could vary dramatically over geological timescales. Periods of high interstellar traffic might have coincided with major evolutionary events in Earth's history, potentially influencing the development of life through the introduction of exotic materials or even extraterrestrial organisms. Intelligence agencies around the world quietly began reassessing their understanding of potential extraterrestrial threats in light of these discoveries. If interstellar objects were common and could potentially carry artificial systems, then monitoring and analyzing such visitors became a matter of planetary security. The realization that dozens of undetected objects might be passing through the solar system at any given time raised concerns about the possibility of covert surveillance or even infiltration by advanced civilizations. The Vatican Observatory, through Cardinal José Funes, issued a thoughtful statement acknowledging the profound theological implications of discovering that the galaxy was interconnected through streams of matter flowing between star systems. If life could spread naturally throughout the galaxy via interstellar objects, it suggested a universe where biological complexity and potentially intelligence were built into the fundamental architecture of cosmic evolution. As September turned to October and 3I/Atlas continued its approach toward the inner solar system, the accumulating evidence painted a picture of a galaxy far more dynamic and interconnected than humanity had ever imagined. Whether 3I/Atlas itself proved to be natural or artificial, its discovery had already revolutionized our understanding of galactic structure and the potential for life to exist and spread throughout the cosmos. The stage was set for the object's closest approach to the Sun, which would provide unprecedented opportunities for detailed observation and potentially decisive evidence about its true nature. Advanced space-based telescopes were being repositioned, rapid deployment missions were being planned, and the global scientific community was holding its collective breath as humanity prepared for what might be the most significant moment in the history of astronomy. Whatever 3I/Atlas proved to be, the universe would never look the same again. As October 2025 arrived and 3I/Atlas began its final approach toward the inner solar system, the global scientific community mobilized for what would become the most intensive observation campaign in astronomical history. Space agencies coordinated telescope time, research institutions pooled resources, and even amateur astronomers contributed to a worldwide effort to capture every possible detail as the mysterious visitor made its closest pass by the Sun. What they discovered during those critical weeks would finally provide the evidence needed to resolve the debate about 3I/Atlas's true nature. But the answer would be more shocking than anyone had dared to imagine. NASA's James Webb Space Telescope was repositioned to provide unprecedented infrared observations of the object as it heated up in the intense solar environment. The European Space Agency's Gaia Observatory contributed precise astrometric measurements, while ground-based facilities around the world maintained continuous monitoring. For the first time in human history, an interstellar visitor would be studied with the full arsenal of modern astronomical technology during its most active phase. Dr. Rachel Cohen at the Space Telescope Science Institute was coordinating the Webb observations when the first high-resolution images started arriving. What she saw on her computer screen made her call her supervisor immediately. The object wasn't behaving like any comet she'd ever studied. Instead of the irregular, chaotic outgassing expected from a natural body being heated by solar radiation, 3I/Atlas was releasing material in highly organized patterns that created geometric structures in its surrounding coma. The infrared imagery revealed internal heat sources that couldn't be explained by solar heating alone. Deep within the object, temperatures were reaching levels that suggested active energy generation rather than passive warming. The heat patterns formed organized structures, geometric arrangements that looked almost like circuit boards or technological components when viewed in false-color infrared. Cohen had spent 15 years studying comets, and she'd never seen anything remotely similar to what 3I/Atlas was displaying. Even more startling was the object's response to the increasing solar radiation. Instead of gradually increasing its outgassing as expected, 3I/Atlas seemed to be regulating its emissions to maintain specific patterns and intensities. When solar wind pressure increased, the object would adjust its gas releases to compensate. When electromagnetic conditions changed, its emissions would shift accordingly. It was as if something inside was actively monitoring the space environment and making real-time adjustments. Dr. Mikhail Petrov at the Russian Academy of Sciences was monitoring the object's electromagnetic signature when he detected something that made him question his instruments. As 3I/Atlas approached its closest point to the Sun, it began emitting structured radio signals, not random electromagnetic noise from heated gases interacting with solar wind, but organized transmissions with clear mathematical patterns. The signals were weak but unmistakable, broadcasting on frequencies that corresponded to fundamental physical constants, like the hydrogen line frequency. The radio emissions weren't just mathematical, they were responsive. When Petrov's team transmitted a series of prime numbers toward 3I/Atlas using the facility's powerful radar system, the object responded within hours with the next sequence of primes in the series. When they sent the first few digits of pi, 3I/Atlas replied with the following digits. The exchange continued for 3 days, with the object demonstrating knowledge of advanced mathematics and apparent awareness of humanity's attempts to communicate. Word of the radio communications spread rapidly through secure channels to space agencies and government facilities worldwide. This wasn't just anomalous behavior that could be explained by exotic natural processes. This was undeniable evidence of intelligence. Something aboard 3I/Atlas was not only monitoring human communications, but was actively responding with sophisticated mathematical knowledge that exceeded anything that could occur naturally. The Vatican Observatory's team, led by Brother Guy Consolmagno, was among the first to publicly acknowledge the implications. In a carefully worded statement, they noted that the radio communications represented the first confirmed evidence of non-terrestrial intelligence in human history. The theological implications were profound, but the immediate focus needed to be on understanding what this intelligence was trying to communicate and what its presence in our solar system meant for humanity. Dr. Lisa Park's analysis of the emission patterns reached its climax during the closest approach, when 3I/Atlas began transmitting what could only be described as a data stream. The mathematical sequences she'd been tracking for months suddenly coalesced into a massive information download, gigabytes of structured data encoded in the object's gas emissions and electromagnetic signatures. The transmission lasted for 18 hours and contained layers of information that would take months or years to fully decode. Initial analysis of the data stream revealed star maps showing the positions of nearby stellar systems with incredible precision, including details about planetary systems around those stars that humanity had never detected. The information was presented in universal mathematical concepts, geometric relationships, and physical constants that any technological civilization should understand. It was clear that whoever or whatever had created this data package intended it to be deciphered by other intelligent species. But the most shocking revelation came when linguists and mathematicians working together began to decode what appeared to be historical records embedded in the data stream. The information suggested that 3I/Atlas wasn't just a probe from another civilization. It was part of a network of such probes that had been exploring the galaxy for millions of years, documenting the rise and fall of countless civilizations across thousands of star systems. Dr. Elena Vasquez at the SETI Institute was part of the team analyzing the historical data when she made a discovery that would haunt humanity's dreams for generations. According to the decoded records, Earth wasn't the first world in our local galactic region to develop intelligent life. The data described at least 17 other civilizations that had reached technological maturity within 1,000 light years of our solar system over the past million years. But according to the records, 16 of those civilizations were now extinct. The patterns of extinction were chillingly consistent. Each civilization would develop technology, begin exploring space, and start transmitting radio signals into the galaxy. They would flourish for a period ranging from a few thousand to several 100,000 years. Then, according to the probe's records, they would suddenly cease all electromagnetic transmissions and show no further signs of technological activity. Their worlds would go silent, their cities would crumble, and their species would vanish from the galactic stage. The implications were terrifying. Either technological civilizations were inherently self-destructive, facing some universal filter that prevented long-term survival, or something in the galaxy was systematically eliminating advanced species once they reached certain technological thresholds. The probe's data didn't specify which explanation was correct, but the consistent pattern across 17 different civilizations suggested that humanity might be facing the same fate that had befallen every other intelligent species in our cosmic neighborhood. Government agencies around the world were briefed on these findings within hours of their discovery. Emergency sessions were held at the United Nations, NATO headquarters, and other international organizations as leaders grappled with the possibility that humanity might be under observation by something that had witnessed the destruction of multiple civilizations. The probe's presence in our solar system took on ominous implications. Was it simply documenting another species approaching extinction, or was it somehow connected to the mysterious fate that had befallen so many others? The scientific community was torn between excitement and terror. The data from 3I/Atlas represented the greatest discovery in human history, proof of extraterrestrial intelligence, detailed information about galactic civilizations, and unprecedented insights into the structure and history of our cosmic neighborhood. But the historical records painted a grim picture of humanity's potential future, suggesting that technological advancement might lead inevitably to extinction, rather than expansion among the stars. Religious leaders worldwide struggled to address the theological implications of discovering that humanity was not unique in the universe, but was part of a pattern of intelligent species that seemed destined for destruction. Some interpreted the findings as evidence of divine testing or cosmic judgment, while others saw them as a call for humanity to transcend the limitations that had doomed previous civilizations. As 3I/Atlas reached its closest point to the Sun and began its journey back toward interstellar space, the data transmissions gradually ceased. The object had delivered its message and was now preparing to continue its million-year journey through the galaxy, carrying information about humanity back to whoever had created it. The brief encounter had lasted only a few months, but it had fundamentally altered humanity's understanding of its place in the universe and its prospects for long-term survival. The departure of 3I/Atlas from our solar system marked the end of its active data transmission, but the beginning of humanity's struggle to comprehend and respond to the revolutionary information it had provided. As the object disappeared back into the darkness between stars, carrying with it detailed observations of human civilization, the world was left to grapple with evidence that challenged every assumption about intelligence, survival, and our future among the cosmos. The data analysis teams worked around the clock for months after the encounter, gradually decoding layers of information that painted an increasingly complex picture of galactic civilization. The probe's records didn't just document extinct species, they revealed a galaxy that had once been teeming with intelligent life, but was now largely silent. Advanced civilizations had arisen on thousands of worlds over millions of years, but the vast majority had vanished after relatively brief periods of technological development. Dr. Jennifer Walsh, who had initially dismissed the alien probe hypothesis, found herself leading a classified government task force analyzing the implications of the 3I/Atlas data. The information revealed technological capabilities far beyond human achievement, faster-than-light communication networks, stellar engineering projects, and artificial intelligence systems that operated on galactic scales. Yet despite these advances, civilization after civilization had ultimately failed to survive. The patterns of extinction became clearer as more data was decoded. Most civilizations seemed to destroy themselves through warfare, environmental collapse, or social breakdown within a few thousand years of developing advanced technology. But a significant minority had vanished under mysterious circumstances, simply ceasing all activity overnight without any apparent cause. These sudden extinctions were particularly troubling because they suggested external threats that could eliminate even the most advanced civilizations instantaneously. Perhaps most disturbing was the revelation that some extinct civilizations had been aware of their impending doom. The probe's records contained final transmissions from several species, desperate attempts to preserve their knowledge and culture before whatever was destroying them completed its work. These messages spoke of invisible enemies, incomprehensible forces, and the gradual realization that their technological advancement had attracted unwanted attention from something vast and malevolent. The Vatican convened an emergency theological council to address the religious implications of the 3I/Atlas Atlas revelations. Cardinal Jose Funes issued a statement acknowledging that the discovery of widespread galactic civilization, followed by systematic extinction, challenged traditional concepts of divine providence and humanity's special place in creation. The Church would need to develop new theological frameworks to address the possibility that God had created countless intelligent species, only to allow them to be destroyed by forces beyond their comprehension. Other religious leaders struggled with similar challenges. Islamic scholars debated whether the Quran's references to life throughout the universe had anticipated such discoveries, while Buddhist teachers found parallels between the cycle of galactic civilization and extinction, and their concepts of cosmic cycles of creation and destruction. The revelation that intelligence might be common, but survival rare, forced every major religion to re-examine its understanding of existence, purpose, and divine intention. The scientific community faced its own crisis of confidence. The discovery that technological advancement might be inherently self-destructive or attract external threats challenged the fundamental assumption that progress and exploration were inherently beneficial. Some researchers began questioning whether humanity should limit its technological development or reduce its electromagnetic signatures to avoid whatever had destroyed so many other civilizations. Dr. Avi Loeb, vindicated by the confirmation that 3I/Atlas was indeed an artificial probe, took little satisfaction in being proven correct. The data revealed that the probe network was ancient beyond imagination, possibly millions of years old, suggesting that whatever civilization had created it had either achieved unprecedented longevity or had vanished long ago, leaving behind only their automated observers. If the probe builders had survived, their silence was almost as troubling as the extinction of the civilizations they documented. Government agencies worldwide began developing response strategies for what intelligence analysts termed the 3I/Atlas scenario, the possibility that humanity was being observed and evaluated by unknown entities with the power to determine our species' survival. Military planners struggled with the impossible task of defending against threats that had destroyed civilizations far more advanced than our own. Diplomatic corps attempted to draft protocols for potential contact with the probe's creators, though the vast timescales involved made such contact unlikely in human lifetimes. The psychological impact on global populations was profound and varied. Some people descended into despair, believing that humanity was doomed to repeat the pattern of extinction that had claimed so many other species. Others found motivation in the challenge, arguing that awareness of the threat gave humanity a chance to avoid the fate of previous civilizations. Religious movements emerged claiming that the 3I/Atlas data was either divine warning or demonic deception, while secular organizations formed to promote human unity in the face of potential existential threats. Educational systems worldwide began incorporating the 3I/Atlas revelations into their curricula, though the traumatic nature of the information required careful consideration of how to present it to young minds. The discovery that intelligence was common, but survival rare, fundamentally altered humanity's self-perception and raised difficult questions about the value of technological progress and exploration. The space exploration community found itself divided between those who advocated for aggressive expansion to spread humanity across multiple worlds and star systems, and those who argued for caution to avoid attracting the attention of whatever had destroyed previous civilizations. Mars colonization projects accelerated as governments and private organizations sought to establish self-sustaining human settlements beyond Earth, while others questioned whether such expansion might only hasten humanity's encounter with galactic threats. Scientific research programs were restructured to focus on understanding the mechanisms of civilization collapse and potential external threats. SETI programs expanded their scope from seeking radio signals to looking for evidence of the systematic destruction of technological civilizations. New telescopes were designed specifically to detect the signatures of extinct civilizations, dead worlds with the remains of cities, abandoned megastructures, and other archaeological evidence of vanished intelligence. As months passed and the initial shock of the 3I/Atlas encounter began to fade into acceptance, humanity slowly adapted to its new understanding of the universe. The probe's data continued to yield new insights into galactic history, stellar engineering techniques, and the potential threats facing technological civilizations. Each discovery added to humanity's knowledge, while reinforcing the sobering reality that intelligence and technology provided no guarantee of survival. The object itself continued its journey through interstellar space, now carrying detailed information about human civilization back to its creators, or to whatever network of artificial intelligence guided its mission. Whether that information would be used to help humanity avoid the fate of previous civilizations, or to add Earth to the growing list of extinct worlds, remained an open question that would haunt human consciousness for generations to come. The 3I/Atlas encounter had answered the age-old question of whether we were alone in the universe. We were not alone, but we might soon wish we were. The galaxy was full of the ruins of civilizations that had asked the same questions humanity was now asking, and their silence served as a chilling reminder that intelligence, no matter how advanced, was no match for the unknown forces that shaped the cosmic order. As humanity looked up at the night sky, the stars no longer seemed like distant beacons of hope and possibility. They had become monuments to countless civilizations that had risen, flourished, and vanished, leaving behind only their questions and the automated observers that continued to document the brief flicker of intelligence in an apparently hostile universe. The age of innocence was over, and the age of survival had begun.